Hello everybody. Today we'll learn MM1K system, model system. MM1K means as revision. 1 is M, is Poisson arrivals. Second M is exponential service. Third is for one server, means one server. Now we have K. So the system size is finite now. It's not infinite. It's finite equal to K. And the remaining 5 and 6, okay. The K will be maximum K customers can enter the system, Q plus server. 5 will be also infinite population, which means this model infinite customers can be served in this model. 6 by default will be first come, first serve. Okay, this is fast revision. Now, this model can reach stability conditions even, listen carefully, even when lambda bigger than mu, because the size of Q is limited and will not grow indefinitely long. We don't have infinity here. So the system will drop incoming arrivals when it's saturated. Thus, after saturation, we assume lambda equal to 0 for n bigger than k to calculate our equations. So this is the model, as you can see. Now lambda will be bigger than mu, so rho, it's bigger than 1 in this system. So the entering rate will be lambda E, effective lambda, who enters in the queue with finite size k. Okay, here in the queue we have k minus 1 and 1 in the server. So it will be k, 1 plus k minus 1 here. And we have lose customers here, drop the customers by lambda b. So total lambda will be equal lambda e who enters plus lambda b who drop or exit or return or lose. So if in this model, if rho equal lambda over mu less than or equal to 1, no saturation. Then the system will not be MM1K. So in this model, rho must be bigger than 1. So as you can see here, this model is like opposite than MM1, as you can see. So here we have rho bigger than 1. Okay, Khalid.
يا دكتور.
Okay, لاحظت this model rho bigger than 1. In your midterm, we'll solve it today, tomorrow. We'll solve it tomorrow. So, okay, in the equation in the midterm, ما فيك تعتمد الرو. Okay, حسب الموديل لأنه.
اوكي ماشي.
Okay, now let's begin. What is the difference between? The first difference here is rho must be bigger to 1 to be named MM1K. If less, no saturation will be similar to MM1. Okay. In MM1K steady state distribution, like MM1, Pn equal rho n P0. But this time, n is limited from 0 to k, not to infinity. That's the difference between MM1K and MM1. The same formula, but here it's limited. N will be maximum equal k. The same as before, summation n equal to 0 to k this time to k Pn equal to 1. The summation of all probability of Markov chains equal to 1. So equal P0 summation n to k rho n. So after using this summation formula in mathematical, which say summation n from 0 to k, not infinity, from 0 to k, xk equal 1 minus x power k plus 1 over 1 minus x. This is given equation in mathematics. So we can solve P0. So P0 equal, okay, we imply this on this. P0 equal 1 minus rho over 1 minus rho k plus 1. Because P0 equal 1 over this. Here, P0 equal 1 over this summation. Okay, this summation will be 1 minus rho k plus 1 over 1 minus k. تطلع لفوق. Okay, هون بالعكس لأن هون بالانفرس 1 over. So P0 equal 1 minus rho over 1 minus rho k plus 1. Okay, this is different than MM1 because in MM1 we have summation of Pn from n equal to 0 to infinity. Okay, so what are the measurement of performance in this system or model? The new features here, with the new metrics here, we have effective arrival rate, lambda E, lambda effective. Customer can enter the system. So lambda E equal lambda times all the probability from P0 to probability K minus 1. Don't forget we have 1 on the server. We have customers in the server. So P0 plus P1 plus P2 plus probability K minus 1, which is equal to 1 minus Pk inverse. Okay? This is lambda E equal lambda times 1 minus Pk plus ineffective arrival rate lambda B. Customers cannot enter the system will be the opposite in this. Lambda B equal lambda times Pk. If we added together equal lambda. Add them together equal to lambda. Okay? This is new in this model and P0. Any question for this? Okay. Utilization of the system U at saturation, U equal 1 minus P0 equal rho E. Rho effective equal lambda effective over mu. So we work only in lambda E, which the customers enter the system. We ignore lambda B, okay, to make our equations calculated. Okay, now for steady state, for assumption we make the L average number of customers in the whole system always will be summation of NPN or IPI from N or I equal to 1 to K, which is equal this big equation. Then we can calculate everything from this relation. Then WQ equal W minus 1 over mu. Then LQ equal WE WQ, lambda E WQ. Then W equal L over lambda E. So first we calculate L in two methods here. Here we can solve it in two methods. In big equation or in summation. If K is small, this method maybe will be better. Maybe. This method maybe will be better. Okay? Now, example. Consider the car wash station here. Assume that the car is not allowed to wait on the side of the road. ممنوع النطرة برا. Okay? Only 6 cars can wait inside the station. So here we have limited cars. So maximum 6 cars can wait here inside the parking, inside the station. Also, a driver is hired to move cars from parking to the machine. Okay? We have employee called driver. This machine is automatic wash machine. Automatic, okay? The driver takes an average 2 minutes to move the car from this inside parking to inside the washing machine. Now, assume that the arrival rate is 9 cars per hour and the washing time is 6 minutes. So, here, the driver, after the car enters the system, will wait. Then, when it's turned the car, the driver will drive this car and enter the machine in 2 minutes. So we have here 2 minutes, and washing time is 6 minutes. Assume Poisson arrival and exponential service. Answer the following questions in steady state. So we have assumed that we have MM1K here. Okay. What is the average number of cars waiting in the station, in the whole station? What is the average number of cars waiting in parking inside the station? On average, how much is take for a customer until he leaves the station? يعني هون big W. First one L, second one LQ, here big W, here WQ. On average, how much is take for a customer until he leaves the parking inside the station? So WQ, W, LQ, L. So we must calculate all. Fifth question, if the station works from 8 a.m. to 8 p.m., how many cars washed per day on average? Now, the new question here, how many cars lost per day on average? We have lost cars, okay? We have lambda B here. Okay, we'll solve this example. First, before answering the questions, always we want to calculate some metrics like lambda equal 9 cars per hour, service time equal driving time plus washing time. Okay, so driving time equal 2 minutes and washing time equal 6 minutes will be equal 8 minutes. Now we can calculate mu. So mu equal here 1 over 8 cars per minute equal 60 over 8 cars per hour. So 7.5 cars per hour. As you can see here, lambda bigger than mu. So it's MM1K. It must be lambda bigger than mu. Else it's not MM1K. Will be always MM1. So mu will be 7.5 cars per hour washing service time. Now also we want to calculate rho. Rho equal lambda over mu equal 1.2 bigger than 1. Now we want to calculate k. K equal maximum number of customers or cars of waiting cars inside the station plus maximum number of cars or washing cars inside the server. So we have here 6 plus 1 in the server. We have here 1 server. So 6 plus 1 equal to 7. So this model is MM1, 7 minus 1, 6. 6 waiting and 1 serve to be served. Okay? 1 inside server and 6 waiting inside the station. Okay? Also, here in this model, we have a new matrix to calculate, like lambda E. Lambda E equal lambda times 1 minus pk. Here el k equal to 7. So equal lambda times 1 minus p7. How to calculate p7? First, we want to calculate p0. P0 equal 1 minus rho over 1 minus rho power k plus 1. We add this calculation to get 0.061. The probability that no cars in the system, the probability P0, no car in the system. The probability that no car in the system will be 0.061. Okay? يعني 6%, 6.1%. Now, we have this equation, Pn equal rho n P0, P7 equal K here 7. Maximum n to get here in the system is 7. P7 equal rho 7 P0. Simple calculation to get 0.218. So what is the probability that the station is full? P7 is full, P0 is empty. When it's full, it's 21.8% only. Empty will be 6.1%. Full will be 21.8%. Okay? 100% will be in average. L. It's L. So, now, after calculating P0 and P7, and always we must calculate them, P0, P7, for MM1K. Always P0, PK. Always calculate them to get lambda E equal lambda times 1 minus K, 1 minus P7. Simple equation, 9 times 1 minus P7 equal 7.038. So lambda E equals 7.038. Now, we can calculate L. Okay. Just in this, we calculate in the big equation here, given rho 1 minus 2, K equal to 7. Okay. K plus 1 equal to 8. Rho 1.2 power 7 plus 7 rho 8 power 8 over 1 minus rho k plus 1. So this is calculation to get on average, here the probability that inside the station will be 4.4 or 4.5 cars per hour, this is the probability will be 100%. Okay, so L, the average number of cars enter the system or inside the system will be 4.47 cars per hour. Now we have a mu. Okay, so we calculate W, waiting time. Waiting time equal big L over lambda E equal 4.47 over 7.038. Already calculated this, equal 0.6 hour, around 38 minutes. Okay. As you can see, this model is almost real. When we wash our cars in the station, around 40 minutes, as you can see. إذا كنتم ملاحظين، إذا في عجقة كتير تقعد ساعة. So now we can calculate WK, Q, W minus 1 over mu equal 0.5 hours or 30 minutes. Last, we can calculate LQ, which equal WE, lambda EWQ equal 3.5 cars per hour. So, from this matrix, we conclude that an average waiting car inside the system or enter the system 4.4. Inside the queue, an average number of cars is 3.5. The average waiting time inside the system, 38 minutes, or inside the queuing, which means the parking inside, 30 minutes. So, any question for now? Any question for this?
دكتور
تفضلي.
أنا جيت مؤخرة. أول شيء صباح الخير. بس بدي أعرف شو اللامدا إي. أنا جيت مؤخرة.
جيت
يعني
مؤخرة.
شو الفرق بين
هلا
لامدا ولامدا إي بس؟
بتشوف الجراف قبل. يلا هلا بنخلص وبرجع لك. اوكي خلص وبرجع لك. يلا
أوكي.
يلا لانه بالاول بدك ترجعنا على الاول. اوكي
يس مش مشكلة.
يلا هلا بس اخلص بوقف التسجيل وبرجع لك. اوكي اوكي. Now the question will be, if the station works from 8 to 8 a.m. to 8 p.m., how many cars washed per day on average? So working hours per day is 12 hours per day. So car washed per hour will be lambda E equal lambda times 1 minus pk, already calculated, 7.0 cars per hour. This is car washed per hour. Car washed per day times 12 will be 84 point, which means 84, okay? 84 cars per day. Now the question will be, how many cars lost per day on average? Lost. We have here lost. Car lost per hour will be lambda B. Okay. Lambda equal lambda E plus lambda B. Okay. So lambda B equal lambda pk, opposite than this, 1 minus pk. Pk equal 9 times P7. P7 already calculated. So will be around 2 cars per hour. Per day times 12 will be around 23 cars per hour. Okay? Okay. Any question here? Mariam, I will answer your question. Okay. Any question for this model? So, in this model, summary, I will make fast summary. In this model, we have MM1K, we have lambda E, cars or customers can enter the system, infinite K size. We have here MM1, so 1 customer inside the server and K minus 1 inside the queue. So here we have lambda bigger than mu. Here in this system, lambda will be divided by 2. Lambda E enters the system. Who enters the system? To calculate its stability condition, to make our equations, okay? And the others will not enter the system. We call it lambda B, okay? Not entering the system. So lambda equal lambda E plus lambda B. Here we must have row bigger than 1. We must have row bigger than 1, okay? This is lambda E and lambda B. How to calculate? We have these equations. P0 equal 1 minus rho over 1 minus rho K plus 1. Okay? Always we have the same probability equations. Pn equal rho n P0. But now in this system, n, it's not infinity. N will be finite. Maximum value will be K, from 0 to K. Not infinity like MM1. Okay? That's why we have this equation. Okay? So lambda E, its effective arrival rate equal rho times P0 plus P1 plus P2 plus Pk minus 1, which is equal 1 minus Pk. And ineffective arrival rate, lambda B equal lambda times Pk. Okay, and we have utilization here. Utilization of the system 1 minus P0 equal rho E equal lambda E over mu. Okay, any question here? Okay, tomorrow in our lab we'll make a big, very big model example on this. Will be business plan for a real car wash station. Real value. Okay, tomorrow we'll make a big question. It cost us around 2 hours to calculate them, to make the study, business study, business plan study of financial study full. How many we lose, what is the profit. في كتير اشياء بالبزنس هناخدها tomorrow. For now, any question for this?
أنا عندي سؤال بس. بهالموديل على طول في خسارة صح؟
اكيد، هذا الريل. انتبه، هذا الريل MM1.
يعني بس يكون بهالموديل يعني في خسارة.
اكيد
اوكي ماشي.
انتبه، اكيد خساره، بس هون بكره حناخذ هالخساره كيف بدنا نحاول نخففها. انتبه، نخففها، ما فينا نلغيها. الخساره ما بتنلغى، بس نخففها، نعمل مانجمنت. اوكي، على طول في خساره هون. فعليا اذا بتشوفوا فعليا بالريل لايف هذا الموديل هو الصح. MM1 is imaginary model. ما في شيء اسمه MM1 بالعالم. infinity customers بيفوتوا. MM1 we have infinity customers in the queue. ما بتزبط، شيء غلط. اوكي، فبالمطعم عنده عدد طاولات معينه في كي. حتى بالراوتر بالجيت واي اللي حليناه لاست لاب، بالجيت واي بالراوتر في بفر سايز، في الرامات الرام في limited size of RAM, so we have limited number of packets inside the router, so we have K size في buffer. In real life, in real application, this is typical real. K will be typical. اوكي، هلا كبرنا الكي، حسنا الموديل، خففنا خساره. صح، بنكبر كي بنخفف خساره، هيك بتصير. نلعب بالكي لنخفف خساره. lose, always we have lose, always we have lose. okay, K bigger, maybe we lose a little, maybe. okay, it depends. Tomorrow at our lab we'll make an outside example from this course. Outside example for this course, we will use MM1K, but we'll make business plan, financial study for our model, okay, in course MBA, Master Business Administration. I took a real example from MBA courses, not in engineering courses, but we'll use MM1K to see in real life what happens, how we calculate this value, what are this value, not written, not like mathematical equations and only calculate them. No, we'll use them to calculate our profit and our lose. How money will profit and how money will lose. اوكي، في خساره في الربح وفي تاكس، في اشياء كثير. هناخد اكزامبل ان شاء الله يخلص معنا بكره. اكزامبل، ريل اكزامبل، ستادي بلان. اوكي، هو مش بالكورس طبعا. اوكي، بس شفتوا، فهمتوا، بدي اشرح لكم اياه لتنبسطوا انه هول عم ناخذهم هلا بالمودلز MM1 وMM1K، وبعدين ان هون بدل 1 حتصير 2 و 3 و 4. شو يعني؟ وات افتر، وبعدين ناخذ الكورس هيك وبس؟ لا، نحن كانجينير لازم نطبقهم. وبكره حنشوف اكزامبل تطبيقي وريل نمبرز، حتتفاجئوا انه قادرين نعمل بزنس بلان لحيلا موديل من بعد ما تاخذوا هذا اللاب. في شويه قواعد بزنس خفيفه، منا صعبه ابدا، منا صعبه، كالكوليشن بسيطه، تاخذ ديسيجن هذا الموديل افضل من هذا الموديل او لا. اوكي اوكي. any question? Okay, good. So I will upload this lecture. Please read it carefully, because tomorrow we'll continue this. We'll continue this. It's the same example, but in real numbers. The same example. Okay, I will upload it now. Please read it carefully. Okay, see you tomorrow.